Before getting started with writing React code, it is very important to know just enough JavaScript to understand what is going to happen afterwards. So most tutorials, most courses make the huge mistake of introducing too much JavaScript in a sense of, okay, let me introduce destructuring, arrow functions, spread operator, rest parameters, default function values, cloning objects, arrays, mapping, class syntax, template literals, promises, async await, context binding, and so on, and maybe the import export syntax, so that you understand how to start writing React code. And then they go on like on a 2-hour long JavaScript course basically embedded in a React course. We're not going there. We're just gonna learn just enough JavaScript so that you will get started. And if you get a sense that you need a bit more review, like JavaScript review, then I recommend quite a lot of things actually. So one of the options are this blog post here, JavaScript tutorial for beginners. If you want more exercises, you can even sign up and you get email exercises. Or I have this bit more advanced JavaScript book, ES6 in practice, or the beginner version, A Practical Introduction to Modern JavaScript. The beginner version is even free at the time of recording. It will not always be free, so grab it as long as you have a chance to. It basically starts with more or less this article, an updated version of this article. So if you get here, you will learn how to start writing JavaScript code. So this is your first JavaScript line, for example. You can press Ctrl+C on Windows and Linux or Command+C on Mac to copy this. Then you go inside here, paste, and there you go, the solution appears. Or if you want to do Hello React, which I didn't think at the time of writing this article, right? So you could write Hello React. There you go, and the solution is already added. You can even do 5 or 6 times 2, and then the result is going to be 12, already printed in the output. And this is why it's important to learn by doing. So whenever you see some code, for example this console log 5+2, immediately run your code somewhere, either in a field like this, so this clips, this is a great tool for blog posts, or you can go to, for example, REPL.it or CodePen, and let's say you have some code that you read. For example, you don't believe me that 0/0 is not a number, then you go here, REPL.it, and type 0 divided by 0, and there you go, the solution is not a number, NaN. So this just helps you get started with the basics of JavaScript. And it's like we go through, we do some basic things like number parsing, like formulating conditions, if-else statements, iterating on arrays, this is gonna be important as well, and so on. So you just go through this and you will learn arrays, objects, functions. So for example, here you have the add function, and if you change add 5,3, then the result is gonna be 8 right away. Or you can learn that you can also add values inside. So 2, 4, for example, and then the result is gonna be 5 + 2 + 4 = 11. So you can play with all these. Then we learn the type of operator, control structures, it's also important, like if-else statements, switch statement, and then at the end loops. So you can even experiment with a lot of different alternatives, and here we have the sum array with a while loop. But if you prefer, then you can right away change this to another loop. So for example, my favorite ES6 loop, because it's so easy to use, is the for of loop. So you would write for let value of values, and then we would have, oops, I need to change the keyboard layout in the meantime because I was writing in a different language not too long ago. So now we have value of values instead of this while loop here, and we will just say sum plus equals value, there you go. And this whole thing here is just substituted by these 3 lines. So this is one way of writing these solutions. Now the console log is not gonna be in effect anymore because obviously we don't need an I anymore. and you can see the result is still 145. So you can experiment with any loops in these code examples, and this is going to be important for you to understand how to write loops and also what JavaScript does with your variables behind the scenes. So it's some insider information on how an array is stored. So you have this numbers equals 1965 and so on. So basically the cheat code of Sonic 2 from 1993, right? If you wanted the level select, it was like you go to the sound test 19, then 65, then 9, then 17. And then we have these values in the array. And you see what an array looks like and how we move forward with changing the I. And this I is basically the index that you can see on the top left of each box inside. So just this article is very much like a tutorial. It's like a full-fledged tutorial that you don't even see in many paid courses. So I highly recommend taking advantage of this. This is available for you for free to get started with JavaScript, and you really have a lot of content embedded in here. And then you can continue with learning the basics of JavaScript with some important and less important topics. Now, which one will you need for React? Value and reference types definitely, cloning objects definitely, some functional programming like map that too, but don't overdo it, it's not that important. Then, well, which is the next one? These three you can ignore for now, although they are interesting for other purposes. And, well, this was the tutorial for beginners that I showed you. Then you might want to check the HTML, CSS, just for the basics, but we will go through this together. And the using strings, so these two string articles as well. These are just for the JavaScript basics. So whenever you go to any article that you can see on the blog, on the left sidebar at the top, you see the categories and you go to JavaScript basics. This is where you find it. You also have some ES6 articles inside. You can check those as well. Like we will build on strings and template literals, that's for sure. ES6 promises, arrow functions, and let's see, maybe use the Webpack as well, using ES6 modules with Webpack. And then if you check out these 4 articles, if you need to refresh anything, then you will be more or less set. So this is instead of a tutorial, so I just give you some written examples and articles and so on. If you want to see the same thing in a video format, then you go to my Front-End Career Accelerator channel, so you're already there, right? So you're watching one of the videos. And, well, there are quite a few videos like destructuring, like the Webpack, it's also in a video format, the arrow functions, default argument values, spread operator and rest parameters. These are gonna be used in the React course. And also check out the class syntax, that's on the right. And let's see what else. I would recommend promises, that's for sure. And basically that's it so far. So I assume that you know what a variable is, so that might not be that important to you at this stage. I will now introduce JavaScript in a relatively fast-paced way for the purpose of creating some markup, some HTML markup that will be usable for us when we will create the flashcards application. So we are learning in a project-based way. Project-based learning means that you learn just enough to fiddle with the technology and the code to do something meaningful. We'll just learn enough JavaScript so that we'll be able to understand the basics of React. So let's jump into it. We have these flashcards. So technically it's a very interesting idea to represent flashcards in JavaScript, like how this works and so on. It's very easy. We will introduce objects and arrays for that. So an object, for example, if you write let card equal, and then you have an object. You saw that a card has a front side, so front side, colon, and then whatever, 9 times 6, for example, 9 times 6. And then you have a backside. And the backside is gonna be 54, that's the result. So this is just one card. And you see that in JavaScript objects, we have this let keyword, which could also be a const. You can use a const keyword because this const means that this card reference is a constant. This card refers to this structure, and this reference cannot be changed, but whatever is inside can be changed. I'll illustrate it a bit better. So we go to pythontutor.com, and once you're inside Python tutor, don't get me wrong, this is JavaScript, so we can visualize JavaScript code as well. We're visualizing the code, and I'll show you what's going on. So we'll just copy this card, and I'll show you how this card is created in JavaScript. And then we'll see card.frontside equals and changed. So these are gonna be the two JavaScript expressions. Let's visualize it, what it looks like. And you see we have two steps. Step number 1, you see the red arrow here. We're gonna run this const card equals whatever. Here you see card, front side 9 times 6, backside 54. And what's the constant? So this constant is really just this arrow. This arrow cannot be changed. This arrow will point at this object forever. So we will never reference anything else but just this object. Whatever is inside the object can be changed. So whenever you see constant, just make sure to remember that it's only about this arrow and nothing else. Then we go to step 2. We change card.frontside to changed. And you see we can do this without a problem. Don't confuse this with, for example, const pi equals 3.14. For example, there is this famous version of pi that you use for circle, perimeter, and also area calculations. Now here, if I say pi equals 2, then let's see what happens. Let's visualize the execution. So step number 1 and 2 are the same, and then we create this pi constant. And as soon as I say pi equals 2, there is an error. You can see type error, assignment to a constant variable. So this is what cannot happen with constants. That if you have a value, for example this 3.14, this should not be changed. Or you have a value that basically points at another object or array. That value, this value inside the blue area, that's what cannot change in case of a constant. So for example, if I say card equals something else, so card equals an other object, we can create an empty object like this, then this is what cannot change. So visualizing the execution is taking some time, but soon hopefully it's gonna appear on screen. Maybe there is an error, so live recording, it's always problematic whenever we have this. So maybe I'll just reload the page and then it's gonna be easier and faster as well. So visualize the execution of this. I'm pasting it, and there you go, we managed to have a shortcut. So first two steps are the same as before, front side, back side, but then card equals empty object. No, this should not work. So we cannot change this pointer. Okay, enough talk. So let's create something that returns some HTML structure. So for that we will create a function get card template. Okay, so we're gonna do get card template, and inside this function parameter, a function argument, we have a card. So this is just one card. This card is just a formal parameter of the function. This card has nothing to do with this card. So we can just change this to first card, just for clarity. So now we have get card template, and this should return some template. And now this is gonna be very, very React-like. So you see that you have this card, For example, div class name equals something, onClick equals something else. Now we're gonna make some changes. So we're gonna make just a bit of change to this, because here we're gonna display both the front side colon and the back side. And let's make this, instead of a div, let's make this an unordered list. You know, in HTML, the UL tag stands for unordered list, and the li stands for list item /li here. Li backside text, whatever it is, /li. And we're gonna do some things about this, so don't yet draw any conclusions. This is incorrect so far. This is gonna be more correct in React. Now, this is not yet JavaScript. To make this more JavaScript-like, I'll introduce something that we call template literals. So with template literals, we have a string, so some text equals ABC. Okay, this is, if you write text, then you get ABC. It's that easy. Now, we also have a backtick, a template literal. So we'll have double text, and if we write this backtick, the backtick is just below your escape key, by the way. Then we can create, first of all, multi-line strings, which I won't be able to demonstrate here in this right-hand side prompt. But you know, you can create technically multi-line strings, and you can also insert other variables inside. So for example, if you write $, and braces, then whatever is inside, it's a JavaScript expression and it's evaluated. So you have text twice, for example, that's why it's called a double text, and you also have 5 + 2 in the middle. And if you evaluate that, then double text is gonna equal to ABC 7ABC. Why is that? Because the value of text is ABC, you can see this at the top, and we inserted this text twice. And we also inserted the value of 5 + 2, which is 7. So later we will do something very similar in React. Right now we're still in JavaScript world. So to make this code work in JavaScript, we'll have to start a backtick here, and we'll have to end our backtick here. You see that the color of all this text changed, which means that this part is interpreted by JavaScript as a string. So instead of text, we're gonna use card.frontside, by the way, as the JavaScript expression, and card.backside here. Notice that the colors didn't change at all here. So the reason why the colors didn't change is that I intentionally forgot adding the $sign, you see? Now, if we add the $sign, you see that this becomes a JavaScript expression. Let's first not add the $sign, and let's see what the result of calling the getCard template with the first card is gonna be. So this is just some JavaScript so that we'll be able to do our work later with React. So this is a template right away. You see that we have this unordered list item, and these things in here are printed straight away without evaluation. But as soon as I change this to a $, like this, then magic, you see that the 9 × 6 and the 54 appears. Why is this 9 × 6 and not 54 right away? Well, the reason is that this is a string, and the string is not evaluated, the string is just inserted. So, you know, to evaluate a string, you have to type this eval, and then, for example, I think first card is accessible here, first card.frontside, and then you have the 54. Just by getting the value of first card frontside, it's like 9 × 6 still in a string. That's why it's green. So let's delete these unnecessary class name and onClick attributes from the UL, and then we'll just have a getCard template here. So that's it so far. You learned how to use functions. If you don't know what functions are in general, think of them as vending machines. You put in some coins, like the card, and then after you put in the coins, you get some results, and these are the results that you can see here. It's very much like, you know, back in the days when there was like, for Europeans it was like 40 degrees, for Americans it was like 110 Fahrenheit degrees, whatever it means, and it was very hot, let's put it this way. And I went to a vending machine. Unfortunately, that vending machine had a discount. And that discount, not discount, like some promotion or something, that most of the time you get a cold beverage, like Nuka-Cola or whatever else. And obviously you want to drink, right? So you, in that situation when you're dehydrated, the first thing that you want is a drink. But as a promotion, sometimes you get a high quality t-shirt randomly. So it's like super high quality t-shirt. And now think about it. You get the high quality t-shirt sometimes, and it's let's say its value is like 10 times the value of the cola. But when you're dehydrated, you just want the cola, right? So that's kind of obvious. And I put in the vending machine and I got the t-shirt, and I didn't have more change with me. So this is why it's important to exactly specify that if we have these inputs, the results should exactly solve what, so the results should describe the results of this getCardTemplate function. You shouldn't do anything else. So you shouldn't start setting like, if you're lucky, for example, then return a t-shirt instead. So you shouldn't do anything like this. You should just focus on what this text description does, getCardTemplate, and just return the card template and nothing else. Don't change other variables, don't change the values inside the card, don't do anything else. It's very important in JavaScript and in any other language. So you see that you supply the card, and this supply is here. So it's like we supply the first card here. And we have the front side, back side inside. It takes the front side and back side out from the card. And that's it. That's all you need. And well, this is a very easy type of description. Now, I'm not gonna get into the details right now, but after you watch my arrow functions and destructuring videos, then you will get away with, for example, const getCardTemplate equals card arrow and backtick. And well, there you have the same UL and list item, but instead of this card, you can just write a parentheses, an object, front side and back side, and just delete these things. So if you see this function, and I show you that it works just like the other one by commenting this out. So let's run it. Yeah, it's still working, same way. Now, if you see this function, you know that you have understood the basics of destructuring and also arrow functions. Let's see what's going on, like step by step. So here we have this getCardTemplate. Instead of this function keyword, first of all, you can do const getCardTemplate equals function card. This is still JavaScript. It's still basic good old JavaScript, because you can place an anonymous function like this in the place of a variable like const or whatever else. Now, with this format, we can very easily change this to an arrow function by removing the function keyword and adding an arrow here. This means the following. Supply this input to the vending machine that selected the card and expect this response, whatever is in the return value. So this is all that you need to understand about this getCardTemplate. Input, output. And if you just have a return value, then you can also get rid of the braces and just supply the return value. This is basically a correspondence between the input and the output. So we will use that in React quite often, these arrow functions, because they come with another side effect that I will reveal later. It's called context binding. But we will use this syntax, get used to this. And then there is this topic called destructuring as well. So you have a first card. Just accept it for now, and more details are gonna be in the destructuring video. That if you want to create a variable, so for example, a first card or front side variable, so front side variable, then you can put it inside braces and say, dear JavaScript, please give me the value of the front side from the object that I'm writing on the right. And the object is gonna be first card. There you go. And front side is gonna be 9 times 6. Now let me press up twice, and see, instead of the first card, let me supply something like front side is gonna be AAA and back side BBBB. There you go. And this time let's just get the back side out of it. Back side. And then backside is gonna be BBBB, because we're basically matching this backside with this value, and then we're getting the value, well, this key, and we're getting the value out of it. Technically, whenever you see backside, in reality JavaScript interprets it in a way that you write backside colon backside. This is called property shorthand notation, by the way. Okay, so property shorthand object, property shorthand notation, and then you see the two backsides, the keys, and the values are just matched against each other, and whatever is on the right side, whatever value is there, is evaluated and it's put on the backside. This on the left side. So if you want to get both front side and back side, we can do it no problem. Then front side is this, and backside stays BBBB. So this is what's happening here as well. Instead of the card, we can just add front side and back side like this. And then delete the card dot. Because we refer to values inside an object with dot. It's in the beginning blog post. And well, with destructuring we can just get rid of that and write less. So this is the same. If you don't understand this yet, no problem. In fact, I'm gonna use the easier format for now. So you see that we have one card. Now let's have 3 cards this time. So let's add the second card and the third card. I'm just copy pasting, so second card and third card. And we have const cards equals and an array notation with brackets, and first card, second card, third card. And we would like to create all the cards, the markup belonging to all the cards. We can very easily do that actually. So we can just do get card template, first card, second card, third card, and we will have 3 unordered lists like this. So we'll have to add console.log inside, and well, we'll need to add the same console log to the second one and to the third one as well. And now we're gonna get the result like this. So let's run this, and you can see the result here, of course. First, second, third, and obviously you can add the other values. So this is 256, and you have rabbit times 8, and then you have the rab byte, because 1 byte is 8 bits, so I think it works for rabbits too. So now we managed to generate the templates. This is good, but it's not enough, because we never know if we only have 3 cards or 100. And if you have 100 cards, or if you don't know how many cards you have, you're not gonna write 100 lines of code here. That's why we have the iteration, the loops, and also the mapping. So that's what we're gonna continue with. Let's continue with the markup. So as you can see, we already generated 3 unordered lists, and now we have these cards here, and we're gonna now check how to deal with them in an array format. So we don't really want to have this first card, second card, third card after each other. We could also do the following. We could create a loop, a simple loop. So for example, for let card of cards. So like this, card of cards. This for of loop basically gives you everything, every single card from the cards list, one by one. And with these cards, you're gonna be able to print them, you're gonna be able to create call functions and so on. So here we'll just write console.log and get card template and card. So basically that's it. I added some more space here so that you can see what's called where and so on. So you can see that instead of these 3 lines that are gonna be deleted, you can just use an iteration. And then if you run this, then you can see the result, the same 3 card appears. So for example, if we duplicated the 3rd card, so if we add it twice and we run it again, then we would not have to change anything else, and then the 4 items would appear. Great. So now we managed to solve this in a loop format. But this is not how we usually render things in React. Usually what we do is we assemble one element or one component. This works in a way, I'm going to illustrate it with strings. So this works in a way that we have initially an empty component. So for example, let markup. So markup, it's like this code that you can see on the right. This is HTML equals empty string. And whenever we run this iteration for the cards, so whenever we get a card from the card list, we add markup plus equals this get card template. So it's like we add this get card template to the end of the markup. And then at the end, we just console log the markup. And that's it. There will be slight changes because instead of the 2 lines, you will see a bit less, most likely. Yeah, that's it. We only have 1 line now because the console log would insert a new line character anyway at the end. So that's the only difference, but besides that, there is not much that's changing. So let's continue. There is another operation that could completely erase these new line characters, by the way. It is called trim. So if I added the get card template dot trim, it would remove all the new line characters and spaces from the beginning and from the end of the template. So it would remove this part and it would remove this part as well. So we could call the trim and then we would make things more compact. In fact, we could call this trim elsewhere as well. We could call this trim just after the string too, because this can also be called on strings. You see? Same solution. So whenever you want to get rid of these spaces or you want to control spaces, don't forget to use the trim. Alright, so we have the card of cards, markup, and so on. We have another solution, and this is a more common type of solution. So we have markup as an empty array, and instead of adding this to the string, we can just add it to the end of the array. So if we added markup.push, we will do exactly that. So this is markup.push, and now we would have an array instead of a string. So you can see that this is now an array. This is why the brackets are here. And well, we have these new line characters and unordered list and so on. So it's printed in a bit different way because of the way how this right hand side displays strings, but you can see the array. This is here the first element of the array with the front side, back side. There is a comma, and then this is the second element of the array, and so on. So don't get discouraged that you see this result here. It's just that REPL.it has a hard time displaying these values. I'll show you some proof that actually it's easier to display it in other ways, because you can also run JavaScript and the Chrome Developer Tools console. So you open, right click and inspect on the page, and then you will open the Chrome Developer Tools. Normally it will show at the bottom for you and it will look white. It will also be somewhat smaller like this. Now, if you add all the code in here with the markup, then you will see the results. Like, this is the first value, this is the second, and this is the third. And here you see it in a slightly different way. So you see that you can just take JavaScript code from one place to another, and you can display the solution elsewhere too. Alright. Now, arrays are displayed like this. You can also join these markup elements. So if you add markup.join and, for example, an empty string, let's see what happens. So imagine that you have, for example, 1, 2, and 5, and you add the join afterwards. Then you see that the 1, 2, 5 are joined together as one string. So this is what's gonna happen in JavaScript, and then we get our templates back. So this is how we usually render templates in React as well, except that we're not working with strings, but we're working with React elements. So this is the main different thing with respect to what we're doing here. Now, we're still not done, because it's markup and push and join and so on. There is a typical JavaScript way of doing this. And this way is the mapping. So imagine that you have the same 1, 2, 5 array that you can see on the right. And if we map the elements inside the 1, 2, 5 array with, let's say, x to x plus 1. Then what's gonna happen in reality is that we're gonna run this x plus 1 function. So the input is, if the input is x, then the output is x plus 1. We're gonna run this function on each and every element of the array, and the result is gonna be 2, 3, and 6. So it's still gonna be an array, but we're just gonna transform each and every element. And we can also use this to create a template literal like this, that, for example, we have a list item and we place the element inside, so x, and then we place a slash list item. There you go. And then we would have 3 list items inside. And after the mapping, we can obviously join. So this is the way how React normally works. So we have some data in the form of an array of objects. We map them to some markup, some React markup, or here HTML markup, and then we join them in the place where we display this HTML. So let's rewrite this with this mapping. And if it's hard for you, just repeat this part and well, experiment a bit more with mapping, because this will come back in the React course as well. We're creating a template that we're gonna use later. So let markup equals empty string, and the for loop, we're gonna rewrite this because we already have the cards. So if we have the cards and the get card template, then it's gonna be very simple, because we have the cards here. You can just write cards.map, and all we need is, if we have a card, then just return this value here, and then we're done. So this is all we need for the markup, and at the end we might decide on joining. So here I'm gonna also add the let markup equals to the beginning of this. And with this, we would not even need this function technically. So you see that after running this, it's still working in the same way, it's still the same thing. And it works even without this function. So you see that it works without the function. But don't get me wrong, this function is still important, this getCardTemplate. Because what you see here is exactly the definition of the getCardTemplate function. So if I rewrote it as const getCardTemplate, so const getCardTemplate here equals function and card, then what you see on the right hand side is the same thing as this thing. Because instead of this, we could have written just function card and remove this, open a brace, and just write return. And then return the return value, and afterwards close the brace and close everything else. So here you have a full-fledged function. So you have the return value. Here we forgot this parentheses, but they are not mandatory anyway, they are just there. And now you can see that we're talking about the exact same function. So this function card here, until here, is the same as this. So then, if these functions are the same, why not just use this getCardTemplate name? Because if there is an equation sign in between them, whatever is on the right hand side can be substituted or referred to as what you see on the left hand side. So we'll substitute this whole thing by just the name getCardTemplate, and there you go, you're done. Let markup equals cards.map getCardTemplate, and getCardTemplate just takes care of consuming the card and returning the markup. So if you prefer, we could write it like this too. We don't have to, but we can, and then we get the same result again. There you go. But we don't have to, because the getCardTemplate already has this value inside. So it expects a card. So we just supply it the card and get the markup back for each and every value. So now it's a bit easier. I will do one more modification, because it's kind of weird to have this first card, second card, third card named. Like, there is no point in that. Normally we just enumerate. So this is the first element, we place a comma afterwards. This is the second element, then we place a comma. By the way, you can press tab and shift tab to move left and right, indentation wise. So formatting options are quite forgiving when you copy and paste. And now we have the third element as well. And we can delete this first card, second card, third card from here and here as well. So this card's data structure is an array of objects. This is the array and these are the objects. And then we create a getCardTemplate function that returns these backticks. Then we have a markup that maps the getCardTemplate, and then we join the values like this. Technically the join can also be here, and then it would be even cleaner, because we can console log and we can do other things as well. Now you see that these are the unordered lists and list items. If you right click and copy, then we can just go to code pen as well. You see that here is an empty pen. I'm just gonna reload the pen because it seems like it didn't really survive the last couple of minutes of recording. So once I add some HTML like this, and once it builds, then you can see front side 9x6, back side 54. Same thing with the second one, same thing with the third one. So this markup is HTML. So it's a valid HTML. We could do some other things, of course. So for example, adding some style sheets, like for ULs, border, 1 pixel solid red. Let's do that. And then you see that there is some border around it. Actually, black would make more sense. But the issue is that this border takes up the whole line, so this doesn't really make sense. So we could do something like display inline block. Let's see what it looks like. Now we have 3 cards, 3 separate cards, with the front side and the back side on the front side right now, but this might change a bit later. So now we did quite a lot of things. I would like to generate this code though from JavaScript, because this is what JavaScript usually does. And then the next step is gonna be, by the way, then we'll switch from the JavaScript preview, so JavaScript preview is about to end. Then the next part is gonna be getting to know what React markup looks like. So we will learn the basics of JSX, the extended JavaScript syntax that allows you to describe React components, and then we will change this markup to React components straight up. And we will use this markup, of course, to build our application. So let's do that. The first step is that we're gonna just copy with Ctrl-C in Windows, Command-C on Mac, and paste with Ctrl-V on Windows and Command-V on Mac. And then we have the markup. If you open this console, you can see that something is printed to the console, so this markup is there. But let's not just rely on the console. We would like to do the following. There should be some container in the markup. Each time you build a React application, you can do something like div class equals js-root and then /div. You know, in HTML, divs are basically meaningless containers. So this is gonna be the container where all the React magic is gonna happen in your document. We're calling this root because this is the root of the document. It's like the top level elements in the document. Now that we have the root, this JS root on the left, we can just do some JavaScript magic to start rendering something. So we have to write document. On the right you see we're writing JavaScript, in the middle we're writing CSS, on the left we're writing HTML. This is the difference. CSS is for styling, it's like the decoration. HTML is for the structure of the document, so it's like what kind of content we have, but it doesn't really take care of the styling. At least it shouldn't. And JavaScript is for dynamic functionality. So these are the 3 different elements that we learn usually. And React is an extension of JavaScript for the purpose of creating web applications and components and so on. So here we have the div, JS root, that's the root element. We have to select it somehow. If we write document.query selector, then it selects the first element that has the selector .js-root. So this just selects this div that we can see on screen. Actually, not only just the first one, but also the only one, because you don't have other JS root elements. So after this document query selector, we can write, in fact I'm gonna place it here, we can write .inner HTML equals, and then we'll just set it to the markup. That's all. And let's see the magic happen. There you go, we got the cards back. So we managed to generate some proper valid HTML with these get card templates. See, there is the get card templates here, the markup, the document, the everything else. And if I change this from 9x6 to 9x8 and 72, like this, then it changes quite soon. Yeah, now the backside is 72 as well. So it changes dynamically based on what data we get in the cards array. So this is kind of cool, because now we can not just hard code our data in the code, but we can also approach some online server and get some pairs of words or questions answers, like question database, and put it on our cards. Just saying. So there are quite a lot of different options now. So we have discovered. And if you know just this and nothing more, then you can already get started with JavaScript. So the next step to understand is just the basics of React, how React components are written.